welcome back to the shop. Not much going on this week. I've just kind of been in cleanup mode, and I've been trying to organize some of the stuff down here, not necessarily in the shop, but just in the cellar in general. I have another room that I'm building next to this that I'm trying to play with, so you know, finding time for everything is kind of a pain in the butt. But today, what I wanted to do, just for my own benefit, I had mentioned on the last video with the rings that titanium is actually flammable, and it is a component in fireworks. It kind of makes those shimmery, really bright lights. So just for my own benefit, I wanted to see how flammable it is. So we're going to take a few chips of different sizes. We want to bring them outside and see what happens to them when we expose them to a flame. Now I'm going to do low flame. I'm only going to use a lighter to do it. I'm not going to use a torch. Like I said in the other video, I had mentioned when you use a torch to put that band in place, just make sure you brush all the chips out of the way and make sure you know where you're pointing that torch, and you don't want to point them into your chip pile. You don't even want to have a chip pile anywhere near there to begin with, just for that reason. So we're going to run outside and see how flammable it is. And also, James Dedmon had sent me a tool holder that he made, and basically what this is a I believe it was at one point a 1-inch shank CNMG tool holder that he had milled a dovetail slot in it to be able to accept an AXA size quick change tool post. So he sent me one to try out. Now I had mentioned in the carbide video, on the smaller lathes you want kind of a positive rake. You don't want a CNMG, but he said he's had some good luck with these, and so we're going to try it out. We're going to try it out on some steel and some aluminum, and we're going to see what happens to it. See if we can actually do it, how deep of a cut we can take, what kind of a finish we can get, and just see what happens. So he gave me this to try out and to give my honest opinion. And I haven't even put it up to the lathe yet. He kind of pre-adjusted it a little bit, so we'll see how close he is on the center adjustment, just for S&Gs. And I haven't tried this on the tool post. I don't even know if it fits yet. We'll give it a shot. But the only thing I did was there was just a tiny little burr on the inside edge, where it's really hard to get at. I just knocked that off. There was nothing to do with James's machining or anything. There was just a tiny little burr on the inside edge of that dovetail. I was able to just take a needle file and just knock that off. Other than that, everything else is fine. So we'll go over there and we'll give it a shot. So let's go outside and see what happens to some titanium when you expose it to some flames. Okay, so we got some steel wool looking chips here. Some chips from cutting off, and some chunkier chips. And we're just trying to get them going with the good old Zippo here. So let's try the steel wool stuff first. Yeah, that goes up pretty good. Okay. Let's try the parting chips. The jagged edges of them want to go, but looks like it'll take a little more heat to get those going, which I'm assuming the bigger chips won't want to go. So the thicker chips burn themselves out. It seems like that was more the cutting oil wanting to burn off of it, but these little guys, these little chips here, that's definitely the titanium burning. Yeah, that's definitely the titanium itself burning. So, definitely a hazard around flame. Just be aware of that. And that's it. Okay, so we're back inside, and you saw, you know, kind of the result of a low flame test. So if you got that torch into that chip pile, you would probably have a bad day. So just be careful with the stuff. Is all I'm saying. You know, metal flaming up on you is something that you aren't usually accustomed to and you're not looking out for. So just be aware that it can happen. And if you are using the torch around the titanium chips and things, just make sure that your general area is clean, and just make sure you know where that flame is pointed. So let's set up on the lathe and let's try the tool holder that James has given us. Okay, so here's the tool holder, and like I said, I believe it was a 1-inch shank CNMG tool holder that he has milled down to give the clearance necessary to be able to actually adjust this and fit it on a smaller lathe. And he's milled the dovetail slot in there. Now, because it was a 1-inch holder, I think he just had this little nub here is just to get around that locking screw there. And he welded in basically just a stud, and that's your adjustment. And a nice brass knurled screw there, and a plastic washer and a jam nut. So we'll see if she fits right on the tool post. And it slides on there, no problem. And yeah, it definitely locks down. And I actually still have a little less than 1/4 inch of travel on the actual dovetail of the wedge dovetail of the tool post. So it's definitely the right size. Slides up and down nice. Now let's see how well he got center height here. And actually, believe it or not, let me move you over a little bit here. The center height on this, let me get you down. Now this came preset from him, I didn't touch it. Is actually pretty damn close. Pretty damn close. It's like a hair high, if that. Let me see if you can see it better in this direction. You see it a little better. It's just a hair high, but that's no problem. We'll just adjust it down. Right there. There's center height. Alright, so let's put some stock in the chuck and we'll see what happens. Okay, so we have some aluminum in there first, and we'll try that. Aluminum usually doesn't like carbide, it kind of smears, but we'll see how she does with this. So we'll speed up put some speed on the lathe. Put on, let's say, what's a C30, so 10 thousandths revolution, 10,000 feet per revolution here. And we'll try, first things first, we'll try a 50 thousandths cut. I get a little bit of tool push off because of that spiral, you can see. Didn't really weld the chip on there. We'll try a little bit deeper cut. We'll try 100 thousandths. And that is actually too much for my lathe. That's actually slowing the lathe down enough to make the belt slip. So let's actually cut the feed rate down. We're going to half it and see if that does anything different. Alright, the slower feed weight works. I can take 100 thousandths on aluminum, no problem. And actually the finish isn't that bad, really. The finish isn't bad at all. So let's get a piece of steel in here and we'll see what we can do with that. Okay, so I believe this here is leaded steel. So we're going to keep the same speed. Actually, we're going to go, I'm going to do 50 thousandths in feed, 5 thousandths feed rate. Actually, now I'm going to take 100, see how it handles that. It's 150. Let's see if we can do 200. That's a 200 thousandths cut, 100 thousandths per side on a little 9-inch Southbend. How about we see the crazies? It's going to have to catch up to itself. When it catches up to itself, that's a 1/4 inch off the diameter on a 9-inch Southbend. We'll see if we can do it. Bogging the lathe down, but I'll be damned if it ain't cutting. Now that's just, this is just leaded stock, so let's put something a little hotter in there and we'll see what happens. Okay, so what we have in there right now is a piece of 1045, and we'll try 50 thousandths. I slowed the lathe down. This is its slowest direct drive speed. We're still at 5 thousandths per revolution. So start with 50. It shouldn't be an issue. Here's 100. And the lathe doesn't like 100. Yeah, I slowed my feed rate down for this because it was bogging the lathe down to 3 thousandths per inch. 3,000 per revolution. So that's 100 thousandths off the 1045. The lathe can take it, no problem. I highly doubt it's going to want to do 200. Which we'll take off of this side here. We'll try it. And it's 200. starting to bog the lathe down and make the belt slip. So let me just brush this off here. So pretty much zero damage to the tip. And just wipe it off a little bit, because it does have a little bit of oil on there. So there you go. So zero damage to that tip whatsoever. Zero wear. And I mean, took some chunky cuts for a little 9-inch lathe. And you know, these are the negative insert rakes. You can see on the front here, you can see that insert is held down at an angle, negative geometry, which everybody in conventional wisdom says these should not work very well on these lathes, but I'll be damned if it doesn't work. So James, tool works out pretty good, and I'll definitely be using this. I'll put it in regular tool rotation and you know, see how it does with some other materials and just regular work. So just to show you guys, that's what the tool looks like on the tool post, and you just see how far this thing sticks out here. So you're looking at 3/4 of an inch. Pretty much on the nose is the stick out from the face of the tool post to the cutting tip there. So just take a regular tool here. I'm gonna set it. I'm gonna bury the tool holder as deep into the tool. Okay, yeah, that's it. Okay, so this is the regular one, and I actually put this insert holder as deep into the actual tool holder as possible, and still be able to change the tip and see how far that sticks off. So there's an 1/8 of an inch difference. The tool stick out of this compared to the tool stick out of this is only 1/8 of an inch difference. Even though it looks way chunkier, there's only an 1/8 of an inch of difference in the length that this actual tool sticks off that tool post. So I'll be honest with you, I didn't think this was going to work. I thought that this tool holder, this geometry of insert, was going to be too much for this lathe. I didn't think it was going to be able to take that much of a depth of cut. I didn't think that it was going to be able to produce a decent finish. I just didn't think it was going to do what I wanted it to do. But you can tell by the finish on this and the finish on the other pieces, this finish is actually really good, and even the other ones weren't too bad at all. Even on the aluminum, very, very, very surprised. And so James, you were right. These do work out really, really well. And like James said, the inserts for these you can get for pretty much the same price as you can the inserts for these little guys here. The only place that I would see this being a problem is if you're trying to get into someplace tight. Just the actual bulkiness of this, if you know, trying to get up against a tailstock or something like that, and you can't stick this out any further. At least this is a little bit thinner and you can stick it out. But then again, I mean, that's one scenario where you're up in some serious, you know, some type places, something that's not the norm. But all in all, it does work and does you know, does do what you want it to do. So very impressed with that. So thanks, James, and we'll definitely be using this again. So thank you guys for watching this video, and hope you liked it. We'll see you on the next one.